Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the previous videos of the coordinate geometry where I have covered what is the slope of a line, equation of a line in slope form, intercept form and so on. So if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to learn about the parallel and perpendicular lines, and we will also see what is the distance of a point from a line and the distance between two parallel lines. So let us start with today's video. Let us consider two lines L1 and L2. Suppose the line L1 is making an angle of θ1 with a positive direction of x-axis, and the line L2 is making an angle of θ2 with the positive direction of x-axis. And let us take the generic equation of the line L1 to be a1x plus b1y plus c1 equals to 0, and the generic equation of the line L2 to be a2x plus b2y plus c2 equals to 0. Now, since this line L1 is making an angle of θ1 with the positive direction of x-axis, so if we consider the slope of this line L1 to be m1, in that case m1 would be equal to tan θ1. In a similar way, if I consider the slope of the line L2 to be m2, in that case m2 would be equal to tan θ2. So if we rearrange these equations in y equal to mx plus c form, in that case, the slope m1 would be equal to tan θ1, which would be equal to minus a1 upon b1, and the slope m2 would be equal to tan θ2, which would be equal to minus a2 upon b2. Now say the line L1 and L2 is forming an angle of theta between them. So if this angle is theta, this angle will also be theta, because they are vertically opposite angles, and this angle is θ1 and this angle is θ2. So if we consider this triangle, and we know that in a triangle any exterior angle is equal to the sum of the two remote interior angles. So we can say that θ1 would be equal to theta plus θ2. So from here I can write theta to be θ1 minus θ2. Now, if we take tangent on both sides, in that case, this would be tan theta would be equal to tan θ1 minus θ2. Now, if we use the formula of tan a minus b, in that case, this would be tan θ1 minus tan θ2 upon 1 plus tan θ1 times of tan θ2. Now, let us replace this tan θ1 and tan θ2 in terms of m1 and m2. So, this tan theta would be equal to m1 minus m2 upon 1 plus m1 times of m2. Now, this theta that we have considered is an acute angle, so we can put a mod here, because in the first quadrant, that is when the angle is between 0 and 90 degree, in that case, the tangent of any angle would be positive. So the tan of the angle between two lines is given by mod of m1 minus m2 upon 1 plus m1 times of m2, where m1 and m2 are the slopes of the two lines. Now, let us try to find out the condition when the two lines L1 and L2 are parallel. Two lines are said to be parallel when they never meet, that is, the angle formed between these two lines is 0. So the angle theta would be 0, and we know that when theta is 0, tan theta would also be 0. So we can say that the numerator would be 0, so m1 minus m2 would be 0. So m1 would be equal to m2. So that means when two lines are parallel, their slope would be same. Now, if we use the value of m1 to be minus a1 upon b1 and the value of m2 to be minus a2 upon b2, in that case, this would be simply minus A1 by B1 would be equal to minus A2 by B2, which can be rewritten as A1 upon A2 would be equal to B1 upon B2. So that means the ratio of the coefficient of X and the ratio of the coefficient of Y would be equal when the two lines are parallel. Now, let us see the condition for the perpendicular lines. So, two lines are said to be perpendicular when the angle formed between these two lines would be 90 degree. That is, theta is 90 degree. So, tan theta or tan 90 would be simply infinity. So that means the denominator would be 0. So we can say that 1 plus m1 times of m2 would be equal to 0, which gives us m1 into m2 would be equal to minus 1. So that means two lines would be perpendicular when the product of their slopes would be minus 1. Here again, if we use the value of m1 and m2, in that case, this would be minus a1 upon b1 times of minus a2 upon b2 would be equal to minus 1. So if we simplify this, we can write it as a1 a2 plus b1 b2 would be equal to 0. So when the two lines are perpendicular, in that case, the summation of the product of x coefficient and y coefficient would be equal to 0. That is, a1 a2 plus b1 b2 would be equal to 0. Now, let us see this question based on the parallel and perpendicular line concept. Find the equation of lines parallel and perpendicular to the line 2x plus 3y equal to 6 and passing through the point 1, 1. So there are two lines. First line is parallel to this line and passing through the point 1, 1, and there is another line which is perpendicular to this line again and passing through the point 1, 1 again. So let us start with the line which is parallel to the line 2x plus 3y equal to 6 and passing through the point 1, 1. Let us assume that the line which is parallel to the line 2x plus 3y equal to 6 is of the form, say, y equal to mx plus c. Since this line and this line are parallel, so their slopes would be same. So we can say that the slope m would be equal to the slope of this line, which would be minus 2 by 3. So the equation would be y equal to minus 2 by 3x plus c. So if we rearrange this, this would be 2x plus 3y equal to 3c. Now, this is that line which is parallel to 2x plus 3y equal to 6 and passing through the point 1, 1. So this point 1, 1 would be satisfying this line. So if we simply use the value of x to be 1 and y to be 1, in that case, 3c would be equal to 2 into 1 plus 3 into 1, which would be 5. So c would be equal to 5 by 3. So the equation of the line would be simply 2x plus 3y would be equal to 3c, which would be 3 into 5 by 3, that is 5. Now, let us see the equation of a line which is perpendicular to 2x plus 3y equal to 6 and passing through the point 1, 1. Again, let us assume that the equation of the line which is perpendicular to 2x plus 3y equal to 6 is of the form of y equal to mx plus c. Now, since these two lines are perpendicular, so the product of their slopes would be minus 1. So we can write m times of minus 2 by 3 equal to minus 1. So from here, m would be equal to 3 by 2. So the equation of the line would be y equal to 3 by 2x plus c. Now again, this line is passing through the point 1, 1. So this will satisfy this line. So in that case, this would be 1 equal to 3 by 2 times of 1 plus c. So from here, the value of c would be simply minus 1 by 2. So the equation of the line would be finally y equal to 3 by 2x minus 1 by 2, which can be simplified and rewritten as 3x minus 2y equal to 1. So the equation of the line which is parallel to 2x plus 3y equal to 6 and passing through the point 1, 1 is 2x plus 3y equal to 5, and the line which is perpendicular to 2x plus 3y equal to 6 and passing through the point 1, 1 is 3x minus 2y equal to 1. Now, every time we don't have to go via this way as it is too much time consuming. In fact, there is a shorter way by which we can find the equation of a line parallel and perpendicular to a given line directly. Every time when we have to find the equation of a line which is parallel to a given line, we can keep the coefficient of x and y to be same, and we can change only the constant. So here we can see that the equation given to be is 2x plus 3y equal to 6, and the equation of a line which would be parallel to this line is 2x plus 3y equal to 5. So directly we can assume that the equation of a line which would be parallel to 2x plus 3y equal to 6 will be of the form of 2x plus 3y equal to some constant. And this constant we can find simply by using the other condition, that is the line is passing through the point 1, 1. So when this line would be passing to the point 1, 1, it would be satisfying this line. So if we put the value of x and y to be 1 and 1, in that case, the value of k would be 5. So the equation would be 2x plus 3y equal to 5. In a similar way, when we have to find the equation of a line which is perpendicular to a given line, in that case, we can interchange the x and y coefficient and will reverse this sign. Since the sign here is plus, we will use a minus sign here, but if it would have been minus sign here, we would have used a plus sign here. So the equation of a line which would be perpendicular to 2x plus 3y equal to 6 can be taken of the form of 3x minus 2y equal to some constant. And again, this constant we can find simply by using the other condition, that is the line is passing to the point 1, 1. So if we put the value of x and y to be 1 and 1, value of k would be 1. So the equation of the line would be 3x minus 2y would be equal to 1. So we can directly use this shortcut to find the equation of a line parallel and perpendicular to a given line. Let us see one more example to use the shortcut that we have just learned. Find the equation of lines passing through 2, minus 3 and parallel to 3x plus y equal to 4 and perpendicular to 5x plus 2y minus 2 equals to 0. We know that any line parallel to 3x plus y equal to 4 would be of the form 3x plus y equal to some constant, and this line is passing through 2, minus 3. So if we put the value of x to be 2 and y to be minus 3, in that case, k would be 6 minus 3, that is 3. So the equation of the line parallel to 3x plus y equal to 4 and passing through the point 2, minus 3 would be simply 3x plus y equal to 3. In a similar way, the line which would be perpendicular to 5x plus 2y minus 2 equal to 0 would be of the form of 2x minus 5y plus some constant equal to 0. Now again, this line is passing to the point 2, minus 3. So this point will satisfy this line. So if we simply put the values here, so this would be 2 times of 2 minus 5 times of minus 3 plus k equal to 0. So from here, the value of k would be minus 19. So the equation of the line perpendicular to 5x plus 2y minus 2 equal to 0 would be simply 2x minus 5y minus 19 equal to 0. So you can see how we can use these shortcuts directly to find the equation of parallel and perpendicular lines. Now, let us see the perpendicular distance of a point x1, y1 from a line ax plus by plus c equal to 0. Suppose I have a line ax plus by plus c equals to 0 and there is a point P whose coordinate is say x1, y1, and say the perpendicular distance from the point P to this line is say small p. In that case, this perpendicular distance, that is this small p, is given by a x1 plus b y1 plus c upon under root of a square plus b square. And since this is a distance, so we are putting a mod here as distance cannot be negative. Now say the point x1, y1 is say 2, 2, and the equation of the line is say 4x plus 3y minus 4 equal to 0. So the perpendicular distance from this point to this line would be simply given by 4 times of 2 plus 3 times of 2 minus 4 upon under root of 4 square plus 3 square. So if we simplify this, this would be 8 plus 6 minus 4, that would be 10 upon under root of 25, that would be 5 mod. So this would be 2 units. So that means the distance of this point from this line is 2 units. Also, say if we want to find the perpendicular distance from the origin, in that case, the point x1, y1 would be simply 0, 0. So the perpendicular distance in this case would be simply c upon under root of a square plus b square. So the perpendicular distance of the origin from this line would be simply given by mod of c upon under root of a square plus b square. Now let us see the distance between two parallel lines. Suppose if I have these two lines, line L1 and L2, where L1 is given by ax plus by plus c1 equals to 0, and the line L2 is given by ax plus by plus c2 equal to 0. Here you can notice that the coefficient of x and y in both these lines are same, so these two lines are parallel, and we want to find the distance between these two parallel lines. So the distance between these two parallel lines is given by mod of c1 minus c2 upon under root of a square plus b square. For example, say if I have the first line L1 as 2x plus y minus 4 equal to 0, say, and the line L2 as 2x plus y plus 6 equal to 0. So these lines L1 and L2 are parallel lines, and I want to find the distance between these two parallel lines. So the distance between these two parallel lines would be given by simply minus 4 minus 6 upon under root of 2 square plus 1 square, and there would be a mod. So this would be minus 10 upon under root of 5 mod, which would be 10 upon root 5, and this can be simplified and rewritten as 2 root 5. So the distance between these two parallel lines is 2 root 5 units. So we can directly use this formula to find the distance between any two parallel lines. So that's it for today's video, in which we have seen the equation of parallel and perpendicular lines and the distance of a point from a line and the distance between two parallel lines. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel, also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.